Timing circuitry is the heartbeat of our embedded systems as electrical engineers. So many of our designs rely on it, yet it can often be overlooked as superfluous and not a major area for improvement or innovation. Can extra considerations on our timing device selection offer improvements for our products in this all too often overlooked area of electronics? Whether we're designing with a simple microcontroller, an FPGA, or a complex multi core networking processor, as electrical engineers, timing of our system really is the heartbeat of the product that we're trying to create. In a lot of cases, when we're thinking about our clock circuitry or the timing that we're using for our FPGAs or processors, we tend to go to the reference designs that are given to us by our suppliers because we know that's going to work. And the device that we're designing with is very, very complex and the last thing on our boards that we want to fail. But are we making a mistake in doing that? Are there innovations in the area of quartz technology where we could be making benefits to our system? We've seen a lot of changes and developments over the course of the last decade where timing technology has gotten smaller. It's gotten better at power consumption. It's gotten better as far as the accuracy of the actual solution. Today, I have the privilege of speaking with David Meaney, who's the Vice President of Global Technical Sales and Marketing at ECS International, about some of the developments and improvements in quartz technology that have happened over the course of the last decade and more, and what we as embedded engineers should be considering when looking at our timing circuitry of the embedded systems that we're designing. David, thank you so much for meeting with us today.
Thanks for having me, Todd. I'm very excited to be here.
Yeah, I really appreciate it. And this is, I think, an exciting area for us to talk about. And like I said at the beginning, I think something that we as electrical engineers overlook a ton. Quartz technology for timing applications is something that's been around for a very, very long time. And I think it sometimes isn't, the sexiest thing. We don't think about it. It doesn't get nearly as much I think press and fanfare when there's a major advancement in quartz technology, the way that sometimes we see with wide band gap or with the miniaturization of the transistor, things along those lines. What do you see as some of the greatest innovations that have occurred in quartz technology over the course of the last 10 years or so?
Todd, you touched on it. Over the past 10 years, there's been a tremendous amount of engineering put into quartz geometries and performance. Today's quartz crystal blanks offer a lot more performance than they did just a few years ago. We're seeing higher fundamental frequencies, lower jitter and phase noise, tighter stabilities and tolerances, and lower aging performance. And really, the performance of today's clocks is a key factor in the success of today's modern technology. And the markets driving them, as would be, IoT, industrial, automotive, medical, wearable, and the like. And if we want to look at some specifics in quartz crystals, smaller overall quartz crystal blanks with less mass give us those higher fundamental frequencies for high-end communications and other strict performance requirements. But even more important are the low frequencies for consumer goods available in much smaller packages like our industry-leading 1.2 by 1 millimeter package. And also our B-series crystals, they offer much improved aging. From what was 3 to 5 ppm per year for traditional crystals is now 1 or 2 ppm a year for these newer geometries. And they also offer lower load capacitance values for lower startup, lower current during usage. And they do this without increasing any ESR. And if we want to look at maybe some oscillator improvements, ECS's multi-volt technology, which is essentially a variable supply voltage ASIC that we've developed. And what this does is it makes oscillators battery capable with full operation from 1.6 to 3.6 volts. Multi-volt technology also works perfectly with static supplies. So a customer can use them in place of a 1.8, 2.5, a 3.3 volt supply, which also means you have less parts to inventory. And because multi-volt have an internal power regulation, you also get isolation. So your clock is less affected by power supply fluctuations and power line noise. And of course, with all this becomes, improved jitter, improved phase noise. Typically, we would measure clocks in picoseconds of jitter. Now ECS can offer clocks in femtoseconds of jitter. Our LMV series offers world-class jitter at sub 50 seconds of jitter, 12 kilohertz to 20 megahertz. So the improvements are bountiful, and engineers should definitely take advantage of these.
Yeah, no question about it. And certainly, I think, when I started off in electrical engineering, my initial systems were, I needed clocking for an 8-bit microcontroller that went into a very large system in a robot, or, scale was not a factor. They were industrial controls generally that I was working on. Today, with everything moving towards wearables, or wireless, something that's going to go into your cell phone, or just the connectivity, the wireless connectivity of everything, I think, designs have changed a tremendous amount. And so the needs, of new products from suppliers like ECS, I think has to change with it. How have you guys kind of seen that continued, miniaturization and need for smaller and smaller packages and more accuracy impact the way that ECS is going to market with product?
Yeah, I mean, we recognize, and I think just about anybody would recognize just how connected our world is. I think the average person has 5 connected personal devices, and that number is going to double over the next 5 or so years. So ECS looked closely at our product portfolio. We saw a need for product that were very small, used very little power, and performed well under constantly changing environmental conditions. Our latest crystals and oscillators have been engineered to offer great performance regardless of environmental conditions. We have small form factor crystals with low 1 ppm first year aging, oscillators, as we discussed, with 50 femtoseconds of jitter, low
Yeah.
current draw in the microamp range. These are the products that are feeding that insatiable IoT connectivity dragon. And we continue to engineer new products to meet the needs of tomorrow's everything connected world.
Yeah, and I think it's those things that makes it worth the extra design engineering effort to take a look at the timing circuitry. Because, like I said, I think when I had a complex multi-core, Cortex A type of a system I was designing, I was nervous. I definitely would be nervous to change what that particular supplier was telling me they used for the clocking of their system. But I didn't ever spend a lot of time taking a look at the data sheets behind those clocking systems and taking a look at how is this going to derate over time? How's the PPM going to change over the course of years in the field? What is this doing to my power consumption? Is it going to have an impact on my battery life? I think those questions are worthwhile questions for us as engineers to ask as we're looking at what we're kind of being spoon fed from
Right.
the data sheet to say, hey, there may be something better here if I do a little bit of research that can make my end product quite a bit better. I think that's a really exciting thing, and something that's certainly exciting to see ECS and others working on right now in improving what we can do as electrical engineers. Now,
100%.
obviously,
And
yeah,
lean on
sorry, go
us,
ahead.
lean on us to help you with those decision makings.
Yeah.
We understand there are design wedges, and there are things that are behind that may be beyond your control. But where they are within your control, your frequency guys, you should be able to lean on them for decisions and help you steer you towards that product that's right for your design.
Yeah, and that's one of the great things is having that expertise on hand, having engineers that can sit and look at it with you and explain why there's a benefit in making that adjustment or that change is
100%.
definitely helpful. And I think we all could reach out for that help. And ECS certainly has a great network of engineers, along with future electronics engineers who are always certainly there to help. To look at those things and ensure that you're going down the right path, which I think is incredible. Now, certainly as an industry, in the semiconductor industry as a whole, we've seen allocation issues across the vast majority of product areas. And we typically talk about this in microcontrollers a lot, in some of the discrete components, power FETs, voltage regulation circuitry, things like that. We've also seen in the timing area things like, the AKM fire that happened, I think, a year and a half ago now in Japan, where a considerable amount of the world's TCXO crystals were being created, have also happened. How's ECS kind of been impacted by allocation right now? And what are you doing to kind of counteract the lead time trends that we see out there?
Well, I mean, certainly ECS isn't immune to the global shortages, the pandemics, global posturing, that's affecting everybody. So what we
Yeah.
can do is, we have looked at all of our products and we've rationalized what materials get bought and where those finished goods are made. Because of those efforts, ECS has been able to keep materials in finished products in the pipeline and in the developmental funnel. So, I mean, what people want to know is what does that mean to our customers? ECS product throughput more than doubled from 2020 to 2021. And ECS continues to maintain the largest inventory of product in the USA. Our warehouse in Lenexa will typically have $4 to $5 million worth of available to sell product. So while we can't answer every question with it'll ship tomorrow, we're doing everything within our power to make sure that we're supporting our customers.
Yeah, and that's I think the best all of us can do right now in this market. The thing I find so very important in that is communication, communication, communication. I think the faster that we know that there's a need for manufacturing down the road, the faster we can start pipelining inventory, and making sure that our customers are ready to go, have the parts they need, and can get to production. And we can start staging that for them early, so they've got really a just-in-time pipeline.
That's
Lead
that's the
times are what they
benefit
are.
of that's a
Yeah.
benefit of us having future in our in our corner with us. It gives us that ability to turn and or pivot, make changes on the fly, and support whatever the customer's requirements are, wherever they are in the globe.
Yep, always the goal that we've got as a company, and certainly a service that we spend a lot of time talking about in this market, especially. And we want to continue to make sure we're doing the best job we possibly can for our partner customers. So that communication, I think, is just key because it's tough for us to pipeline when we don't know. And the faster that we can know, the faster we can ensure that product is ready to go and move in that direction.
Absolutely.
So, outside of that, looking at the markets that ECS sees as the growth markets and the biggest growth markets for timing and for you as a company moving forward, where do you guys have some of your focus as far as new technologies and new areas that you're trying to grow into as the market continues to evolve?
Yeah, I mean, certainly the market between both technology and COVIDs and other things, ECS has had some great success in a lot of I won't call them new markets. Certainly IoT connectivity markets are the premier drivers. We all know that. But
Yep.
we've also seen tremendous growth in the industrial space. So industrial automation, dark warehouses are help driving manufacturing costs down. And even before the pandemic, the medical industry was pushing for more home healthcare options, to free up beds and let people heal at home. So
Yeah.
the medical area has been a huge growth, but really a rapidly growing segment for ECS has been within our automotive products. A modern internal combustion engine vehicle is going to have more than 80 microprocessors that
Yeah.
need quality timing. And today with EV technology and implementation of hybrid or fully electric vehicles, the number of timing products needed has gone up exponentially. There's no slowdown in sight or predicted. But ECS has also captured other niches for automotive grade products. From the expansion in the medical world and municipalities needing heart monitors and blood glucose meters,
Yeah.
gas and water meters for public service. And they want these things to all be built under the same stringent manufacturing and field performance that the automotive world has demanded for years. So these automotive grade products are engineered to be used in extreme temperature environments, and they're built ruggedized to survive in the harshest of applications. So all of our automotive grade products are built at AITF 16949 factories and certainly certified to the AEC Q200 requirements. So trying to move into these new areas has been kind of a shift, but luckily we saw this coming long before it happened, and we've got those products on hand in future, ready to be shipped to those customers that need them.
Yeah, and certainly some new things that as electric vehicle electrification continues on and we get into more needs for certifications, things that maybe, I'm not an automotive engineer, so I've never designed on that side other than working with many of them. Not something I always consider looking at, is my Crystal AEC Q200 certified? And to know that ECS is pursuing and going down that road and has products in that area, definitely a great thing as we see that sector as one of the fastest growing sectors by far for the semiconductor industry.
And,
Definitely an
and we see
exciting
that,
time.
like I said, in other areas where, municipalities with gas and water metering and, things
Yeah.
that used to be in a closet in a climate controlled area, now up on the roof, they're on the pole. So they definitely need that extra design effort for temperature and or robustness just to survive.
Yeah, definitely, definitely. Always something else, another problem we as engineers have to solve. So that it keeps us employed, right? So that's always a good thing.
Exactly. Exactly.
So, looking at, just kind of closing out, when we look at timing circuitry, like I said, it can sometimes be a little bit tough to look outside of what we're being spoon fed, in the basic application notes that we look at for a customer. There's a lot of different timing options out there, a lot of different crystal companies. Why should an engineer be looking at ECS? What do you guys see as your primary differentiation in the timing space? Why an engineer should be considering your product above all others?
Todd, we talked a little bit about it earlier with the development of products that are meeting all of today's design engineers' needs. They literally can come to us for anything. But honestly, the one thing we hear from all of our customers, responsiveness. Whether it's quotes and samples or a simple phase noise plot. ECS measures our response time in minutes, not even in hours and days. We pride ourselves on this incredible response time of our internal sales team. We have dedicated seasonal technical support. It's available real time all over the world. We've got offices in the Americas, Europe, Asia, and technical support covers all means of topics from design services, schematic and board reviews, board characterizations, simple load cap values. Our sales and technical support teams are here to support our customers and sales channel partners, and we think that's a big difference.
No question about it. I think in this world, we all want answers. We want them immediately. I think we've been trained by that,
Yes.
with the internet to some extent. And I think having a live body that's constantly ready to be there and answer questions, at a moment's notice, that really helps us as electrical engineers because we want to get our designs done and we want to get on to the next thing. We want to get them done well. And having an expert, available to us at a moment's notice, that's absolutely an incredible thing. So
It's how we
very
measure
good.
ourselves.
Yep. Yep. Wonderful. Wonderful. Well, David, thank you so much for talking to me a little bit and giving me some
Thank you.
insights into some of the new developments in the timing industry and where things are going. I think, from my perspective, this has been very eye-opening on how I, as an engineer, I'm going to be taking a look at designs and how I should be considering the timing solutions and take a look at some of the details in the different crystals that I'm selecting, the timing solutions that I'm selecting, that could possibly make my system better. So can't thank you enough for the insights on that.
Well, thank
Thank
you
you
for
so much
having
to
me.
our audience for taking a look at and watching this with us and joining us for this. If you have any questions whatsoever or anything that we can help you out with in your embedded designs, whether it's timing, processors, availability, you name it, we'd love to help you here at Future Electronics within our advanced engineering organization. Please reach out to us at Shaping the Future at futureelectronics.com. Again, Shaping the Future at futureelectronics.com. And we hope you'll join us for our next episode. David, thank you so much for being a guest today. All the best.
Thank you.